In this video, we're going to learn the basics of quadratic function. Before we start, please subscribe to our channel and don't forget to click the bell button to turn on notifications, because more incredible content is on its way. Okay, let's get started. First, I will show you an example so you have a more in-depth impression of the quadratic function. There is a 20-meter fence which can be used to enclose a rectangular area. What is the area of the rectangle with different length values? We assume the length of the rectangle's area is x. 20 meters is the perimeter of the fence's area. Because the area is a rectangle and the perimeter is the sum of twice the length and twice the width can be described as 20 minus 2x divided by 2, which can be simplified into 10 minus x. We know the area of the rectangle is the product of the length and the width. That is x times parentheses 10 minus x, which equals 10x minus x squared, or negative x squared plus 10x. So the area can be described as negative x squared plus 10x. Now let's make a table to see the values better. In this table, the area of the rectangle is y changes when the length, x, changes. This relationship between the two variables can be formed in a function y equals negative x squared plus 10x. Generally speaking, the function is a form of y equals ax squared plus bx plus c, where a, b, and c are numbers and a cannot be equal to 0. The function describes the relationship between the two variables. X is the input and y is the output. The value of y changes when the value of x changes. In other words, its value depends on the value of x. You may say, this looks familiar. Yeah. If y equals 0, the function turns into a quadratic equation, ax squared plus bx plus c equals 0. Actually, the quadratic equation we learned about in the previous videos is a special form of the quadratic function. Please check out the link in the description if you want to learn more about the quadratic equation. Just like the linear function, the quadratic function can also be graphed. Let's try to graph the function of the previous example. In the table, there are groups of numbers: 2 and 16, 3 and 21, 4 and 24, 5 and 25, 6 and 24, 7 and 21, and 8 and 16. All of them should be on the graph. We can see the graph of the quadratic function y equals ax squared plus bx plus c is always a U-shaped curve, which is called the parabola. Now let's talk about some important characteristics of the parabola. First, the coefficient a is very important and can determine how wide or narrow the graphs are, whether the graph opens upward or downward. The parabola opens upward if a is greater than 0. The parabola opens downward if a is less than 0. The smaller the value of a is, the wider the parabola opens, and the bigger the value of a is, the narrower the parabola opens. Second, when we look at the parabola, we can see that it has the lowest point if it opens upward. That means the function y has a minimum value in this case. On the contrary, it has the highest point if it opens downward, and y has a maximum value. The lowest or the highest point is called the vertex. But how can you determine the value of the vertex? The result is when x equals negative b divided by 2a, the function will have a vertex, which value is c minus b squared divided by 4a. Keep this in mind and it will help you solve problems with the quadratic function. Now let's see how to prove it. Let's use the complete the square formula. Just add and subtract b squared divided by 4a at the right side of the function and get y equals ax squared plus bx plus b squared divided by 4a minus b squared divided by 4a plus c. Factoring out a from the first three terms, the function turns into y equals a times parentheses x squared plus b divided by ax plus b squared divided by 4a squared plus c minus b squared divided by 4a. x squared plus b divided by a x plus b squared divided by 4a squared is the square of parentheses x plus b divided by 2a. So we get y equals a times parentheses x plus b divided by 2a squared plus c minus b squared divided by 4a. When x equals negative b divided by 2a, the first part is equal to 0. So when a is greater than 0 and x equals negative b divided by 2a, the function has a minimum value of c minus b squared divided by 4a. When a is less than 0 and x equals negative b divided by 2a, the function has a maximum value of c minus b squared divided by 4a. So we get the value of the vertex negative b divided by 2a and c minus b squared divided by 4a. It's a little complicated, but it can help you understand the vertex better and make you more comfortable with the completing the square formula. Now let's look back at the graph of the quadratic function. Just by looking at it, you can see that it is symmetrical and its line of symmetry passes through the vertex. That means the vertex line x equals negative b divided by 2a is the axis of symmetry of the parabola. Okay, now that we've finished learning the basic concepts of the quadratic function, let's look at an example together to better understand the concept. Y equals x squared plus 3x plus 2. What is the vertex and the axis of symmetry of this function? Here, a equals 1, so we know the parabola opens upward and has a minimum value. To get the value of the vertex, we just plug the value of a, b, and c in. Negative b divided by 2a and c minus b squared divided by 4a. Negative b divided by 2a equals negative 3 over 2. C minus b squared divided by 4a equals 2 minus 9 over 4, which equals negative 1 over 4. So the vertex is negative 3 over 2 and negative 1 over 4. But don't forget the axis of symmetry. It's the vertex line of x equals negative b divided by 2a, which is x equals negative 3 over 2. As we already learned, the graph of the quadratic function f of x equals ax squared plus bx plus c, where a doesn't equal to 0, is a U-shaped curve called a parabola. It always has a vertex value of negative b over 2a, c minus b squared over 4a. The parabola is symmetric, and its line of symmetry is the vertical line x equals negative b over 2a. If you're not familiar with this concept, please check out the links in the description to learn more. Now let's check out how to graph a quadratic function. Theoretically, we just need 3 points to determine the parabola. But if we want to graph it more precisely, it's better to find 5 points on the curve. First, the vertex point, then the y-intersection, and its symmetric point on the parabola. Lastly, we need the 2 x-intersections on the parabola, if they exist. Let's try to graph a quadratic function together, so you can have a better understanding. Y equals x squared minus 8x plus 7. Here, a is greater than 0, so the parabola opens upward. Next, we plug the values of a, b, and c into the vertex value, negative b over 2a, c minus b squared over 4a, and get the point of the vertex 4, negative 9. Now the question is, when does the parabola have a y-intersection? The answer is when x equals 0. Here, y equals to 7 when x equals to 0. So we can get the y-intersection 0, 7. The symmetric point of the y-intersection has the same y-coordinate, in this case 7. Its x-coordinate is the double of the x-coordinate of the vertex, that's 8. So we get the symmetric point 8, 7. The last step may seem familiar because we previously learned the y-coordinate of the parabola's x-intersection equals 0. Plug y equals 0 into the quadratic equation and get x squared minus 8x plus 7 equals 0. It's easy to factor out the left side of the equation with the crossing method, and we get parentheses x minus 1 times parentheses x minus 7 equals 0. So the two roots are x equals 1 and x equals 7, and the x-intersections are 1 and 0 and 7 and 0. Now we can graph the parabola with the 5 points. You might think in some situations when y equals 0, the quadratic function has no roots or that the function has no intersection with the x-axis. How should we graph the parabola in this case? It's a little bit different, but it's not complicated. Let's look at another example together. Y equals x squared minus 4x plus 5. This function can be turned into y equals x squared minus 4x plus 4 plus 1. The first three items on the right side are the square of x minus 2, so we can get y equals parentheses x minus 2 squared plus 1. Since parentheses x minus 2 squared is greater than or equal to 0, parentheses x minus 2 squared plus 1 is always larger than 0. That means the function has no intersection with the x-axis. To graph the function, we have to calculate the value of the vertex first. Because a is greater than 0, the function opens upward and the vertex is the minimum value of the function. Apparently, the function has a minimum value if parentheses x minus 2 squared equals 0. That is when x equals 2, the minimum value of y equals 1. So we get the vertex point of the function 2 and 1. Then as usual, we will plug x equals 0 in the function and get the value of y, which is 5. So the y-intersect is 0 and 5. Now we have to determine the symmetric point of the y-intersect. The x-coordinate of this point is double the x-coordinate of the vertex, and its y-coordinate is the same as the y-coordinate of the y-intersection, so we get the point 4 and 5. We should now find the x-intersection, but there isn't any, so what should we do? It's easy. In this example, the x-coordinate of the vertex point is 2. So we'll just try to determine the 2 points on both sides of the vertex. For example, using x equals 1 and x equals 3. Let's calculate by plugging in x equals 1 into the function. Y equals 1 minus 4 plus 5 equals 2. And we get the point 1 and 2. And then we plug x equals 3 into the function. Y equals 9 minus 12 plus 5 equals 2. And we get the last point, 3 and 2. Now we're done, so you can just graph the function. Next, I will show you how to graph some special forms of quadratic functions, which will be easier. Y equals 3x squared. Here, 3 is greater than 0, so the parabola opens upward. Because b equals 0 and c equals 0, the vertex, the x-intersection, the y-intersection, and its symmetric point are the same point, 0 and 0. So we just need to determine the 4 points, 2 of them on the right and 2 of them on the left. For example, x equals 1, negative 1, 2, and negative 2. When x equals 1 and negative 1, we get y equals 3. When x equals 2 and negative 2, we get y equals 12. So now we just got 5 points easily. The next step is to graph the function. The next example, y equals 3x squared plus 2, opens upward, and because b equals 0, the symmetric line is x equals 0. Y has the minimum value if x equals 0. So the vertex point is 0 and 2. The example is above the x-axis, which means that there are no x-intersections in this case. Besides, the y-intersection 0 and 2 is the same point as the vertex point. So we can take the points whose x-coordinates are 1, negative 1, 2, and negative 2 and get the 4 points, 1 and 5, negative 1 and 5, 2 and 14, -2 and 14, and can graph the function. When we graph these two functions in the same coordinate system, we may find that they are very similar. The parabola of y equals 3x squared plus 2 is parallel to the parabola of y equals 3x squared. It just moves 2 upward from the position of y equals 3x squared. It's interesting, isn't it? In the first example, there are 3 points on the parabola of the quadratic function: 0 and 3, 1 and -1, and 2 and -3. What is the expression of this function then? As we already learned, the general form of the quadratic function is y equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. So all we need to do is plug in the coordinates of the points onto the function and get the equation system with 3 variables. When we plug in x equals 0 and y equals 3, the x-coordinate and the y-coordinate of the point 0 and 3, we get 3 equals c, or c equals 3. We plug 1 and -1 into the function and get -1 equals a plus b plus c, or a plus b plus c equals -1. We plug 2 and -3 into the function and get -3 equals 4a plus 2b plus c, or 4a plus 2b plus c equals -3. Now we get the following equation system: c equals 3, a plus b plus c equals -1, 4a plus 2b plus c equals -3. Next we plug c equals 3 into the other two equations and get a plus b plus 3 equals -1, and 4a plus 2b plus 3 equals -3. These equations can be simplified into a plus b equals -4, and 4a plus 2b equals -6. Does it look familiar? Well, that's because we've already learned these two methods to solve these kinds of equation systems: elimination and substitution. You can check out the link in the description if you want to get a warm-up. Here we will use the elimination method to solve this equation. Multiplying 2 on both sides of the first equation, we get 2a plus 2b equals -8. When we subtract the first equation from the second equation and get 4a plus 2b minus parentheses 2a plus 2b equals -6 minus -8. 4a minus 2a equals 2a. 2b minus 2b equals 0. -6 plus 8 equals 2. That's 2a equals 2, so a equals 1. Plug a equals 1 into the equation, a plus b equals -4, and get 1 plus b equals -4, so b equals -5. Now we have a equals 1, b equals -5, and c equals 3. So the expression of the function is y equals x squared minus 5x plus 3. In the next example, the vertex of the parabola is 2 and -1, and the point 4 and 3 is also on the parabola. What is the expression of the quadratic function? We already know the function is in the form of y equals ax squared plus bx plus c, and when x equals -b over 2a, the function has a vertex. So we get -b over 2a equals 2. Multiplying -2a on both sides, which can be simplified to b equals -4a, we then plug the coordinates of the points 2 and -1 and 4 and 3 into the function and get the equation system. Equation 1, b equals -4a. Equation 2, -1 equals 4a plus 2b plus c. And equation 3, 3 equals 16a plus 4b plus c. As we can see, only 2 equations have the variable c in it. We can get rid of it by subtracting equation 2 from equation 3 and get 4 equals 12a plus 2b. All the terms have a common factor of 2, so the equation can be simplified by dividing 2 on both sides and getting 6a plus b equals 2. From equation 1, we know b equals negative 4a, so we substitute b equals negative 4a and get 6a plus negative 4a equals 2. That's 2a equals 2. As a result, we get a equals 1. Next, we plug a equals 1 into the equation 1 and get b equals negative 4. Then we plug a equals 1 and b equals negative 4 into the equation 2, and it becomes negative 1 equals 4 plus 2 times negative 4 plus c, which is negative 1 equals 4 minus 8 plus c. So we get c equals 3. So now we know the expression of the function is y equals x squared minus 4x plus 3. Let's look at another example. The point negative 1 and 12 is on the parabola of the quadratic function y equals x squared minus 6x plus c. What is its symmetric point on this parabola? In this example, a and b in the function are already known. That means we just need to plug in the points negative 1 and 12 and then get the value of c. The function becomes 12 equals negative 1 squared minus 6 times negative 1 plus c. Remove the parentheses and we get 12 equals 1 plus 6 plus c. So c equals 5. The expression of the function is y equals x squared minus 6x plus 5. As we already learned, the axis of symmetry of the parabola is x equals negative b over 2a. Here, x equals negative 1 times negative 6 over 2, which is x equals 3. Next, we graph the function. The symmetric point of negative 1 and 12 has the same y-coordinate, 12. When we look at the parabola, we can find the distance between the symmetric point and the symmetric line, d1, is the same as the distance between the points negative 1 and 12 and the symmetric line, d2. Here, d2 is the difference of 3 and negative 1, which is 4. d1 is the difference of x and 3, so we plug in x minus 3 equals 4 and get x equals 7. This means the symmetric point of negative 1 and 12 is 7 and 12. Okay, now let's focus on the vertex again. Understanding vertexes is very useful. It can be used to solve many problems in area of maximum and minimum value. Let's look at another example, which will also be the last example of this video. The sum of two numbers is 60. What is the largest value of their product? We assume one number is x and the other number is 60 minus x. So the product is x times parentheses 60 minus x equals negative x squared plus 60x. This is the quadratic function with a equals negative 1, b equals 60, and c equals 0. We already know the function has a vertex when x equals negative b over 2a. Furthermore, a is less than 0 in this function. Therefore, the function has a maximum value when x equals negative b over 2a. Plug a equals negative 1 and b equals 60 into x equals negative b over 2a and get x equals 30. The last step is to plug x equals 30 into the function. It becomes y equals negative 30 squared plus 60 times 30 equals 900. That means the largest value of the product of the two numbers is 900. We're all done. Okay, I think we've learned enough for today. Thank you for your attention. If you have any questions, leave your comments below or email us at question@beat-math.com. We'll try to answer your questions in a future video, and the most common question will be given priority in our next video. See you next time!